In this video, we'll be discussing the basics of probability. Probability deals with measuring how likely it is for something to occur. First, let's look at some basic terms of probability. An experiment is anything which has an outcome. For example, flipping a coin and looking to see what side of the coin it landed on, or looking outside to see if it's raining, or sunny, or cloudy. Sample space. This is the set of all possible outcomes of an experiment, and we will denote this set with the capital letter S. And finally, an event. An event is any subset of the sample space. Let's consider an example. Think about the experiment of rolling a six-sided die, where the outcome is which side the die lands on. The sample space for this experiment would be the set of all possible outcomes. So for this experiment, the sample space S would be the set containing the elements 1, 2, 3, 4, 5, and 6. All the possible outcomes of the experiment. An event is any subset of the sample space. For example, the set E containing 1, 3, 5. This subset represents the event of rolling an odd number on a six-sided die. The event contains every possible outcome that fits the description of an odd number in the sample space. Another event could be the event of rolling a number greater than 4. This event would be represented by the set 5, 6. Notice this is all the outcomes which represent a number greater than 4. Probability is a measure of how likely an event is to occur. So given any event of an experiment, we'd like to be able to figure out the likelihood that that event would occur. Given any experiment with a sample space S containing equally likely outcomes and an event E, the probability of E can be found by counting up the number of elements in the set E and dividing it by the number of elements in the sample space. It is important to remember that all outcomes in the sample space must be equally likely. Remember, the sample space contains the set of all possible outcomes of an experiment, but it's possible to create more than one sample space. The trick is that we have to create the sample space that has equally likely outcomes. For example, the experiment of rolling a six-sided die, we could have created a sample space as follows. We could have said the sample space has two elements. The first element is the outcome of rolling a number less than or equal to 4. The second element is the outcome of rolling a 5 or 6. Notice that these two outcomes represent all the possible outcomes of the experiment. You'll either roll a number less than or equal to 4, or you'll roll a number that's a 5 or a 6. We wouldn't want to use this sample space because these two outcomes are not equally likely. Now let's use this definition of probability to find the probability of rolling an odd number on a six-sided die. The probability of the event E is found by counting up the number of elements in the set E divided by the number of elements in the sample space. For our event E, there are 3 elements, and the cardinality of the sample space is 6, which gives us a probability of 1/2, or 0.5, and it's also reasonable to represent this as a 50% chance that we'll roll an odd number. The probability of the event F occurring, the event of rolling a 5 or a 6, can be found by counting up the number of ways that F occurs divided by the total number of possible outcomes. There are 2 outcomes in the set F out of the 6 possible outcomes, for a probability of 1/3. Let's look at another example using the same experiment. Let's let G be the event of rolling a 7. then what's the probability that G will occur? Well, first of all, we need to represent G as a set. G would be the set containing no elements, or the empty set. Because remember that an event is always a subset of the sample space. So if we were creating the event G, it would contain all outcomes from the sample space that represent rolling a 7. Well, none of the outcomes represent rolling a 7, so G would be an empty set. The probability that G occurs is the number of elements in the set G divided by the number of elements in the sample space. Since G is the empty set, it contains no elements out of the 6 elements. So the probability of rolling a 7 is 0, which makes sense. It's impossible to roll a 7 on a 6-sided die. So we have the definition of probability of an event. The probability of an event occurring is found by counting up the number of ways the event can occur divided by the total number of possible outcomes in the sample space. Recall that this is given that the outcomes in the sample space are equally likely. Another way to represent the same information is to give the odds of an event occurring. The odds of an event occurring are given as the number of ways the event can occur, colon, the number of ways that the event will not occur, so the number of elements in the complement of the event. For example, consider the experiment of drawing a single card from a standard 52-card deck. And suppose that the event E is the event of drawing a spade. Then the probability that E occurs can be found by counting up the number of outcomes in the set E divided by the total number of possible outcomes in the experiment. So the experiment is drawing a single card from a standard 52-card deck. The sample space of this experiment is all the different cards in a standard 52-card deck. So our sample space contains 52 elements. Of those 52 elements, 13 are spades. So 13 cards in a standard 52-card deck are spades. So the probability would be 13 over 52. The odds of the event E, so the odds of drawing a spade, would be found by taking the number of ways we can draw a spade to, that's how you read the colon, the number of ways that we would draw something that's not a spade. So here, there are 13 ways to draw a card that is a spade to the 39 ways that we can draw something that's not a spade. So 13 to 39. You can reduce odds similar to the way that you reduce fractions. So 13 to 39 odds is equivalent to 1 to 3 odds. Note that probability and odds really do provide equivalent information. If you know one, you can always find the other. To do that, we would use the formula that tells us that the number of elements in a set E plus the number of elements in its complement always equals the total number of elements in the sample space, or the universal set. You can think about this from the perspective of a Venn diagram. If you add up everything inside the set, so inside the circle, plus the number of elements outside of the circle, you'll get the total number of elements in the box, the sample space. For example, suppose I know that the probability of an event occurring is 2/5. Then I can find the odds of that event occurring. The odds of the event E occurring are given as 2, because I know that the probability of the event E occurring is 2 over 5, and the numerator of that fraction is the number of elements in the event E, possibly reduced, 2. Now, I need to list the number of elements in the complement of E. Well, the sample space contains 5 elements, again possibly reduced. So 5 minus the 2 in the set E gives us 3. Likewise, if I knew the odds of an event E occurring to be 3 to 4, then the probability of the event E occurring would be given by 3 divided by the total of the number of elements in E and the number of elements in E complement, 7. So 3/7. Again, these may have been reduced numbers. For example, considering our previous example of drawing a spade, the probability reduced to 1/4, but the idea still works. If the probability is 1/4, then the odds are 1 to 3. If the odds are 1 to 3, then the probability is 1/4.